Hello, in today's video we're going to be discussing a topic that we discussed at the beginning of the semester, but now with all of our new knowledge of orbital diagrams and electron configuration, we can discuss the idea of ionic bonds in greater detail and see why ionic bonds form the way that they form. So we know that in an ionic bond, that's a bond between a metal and a nonmetal. So the left-hand side of the periodic table and the right-hand side of the periodic table. Between two elements of those two types, left-hand side and the right-hand side, metal, non-metal, that the metal will give up an electron, or two or three, and form a cation, while the non-metal will gain an electron, or two or three, and become an anion. So now we can identify why this happens and the driving force. We touched base on this before last week, where we discussed a certain metal, why it would lose an electron or two, and why a nonmetal would gain an electron or two. So we're just going to quickly review that, and then we're going to form a Lewis dot structure for our two different ions, yeah. So let's see how this works. Let's look at an example. Let's draw the electron configuration, draw the orbital diagrams of a metal and a nonmetal, and see how these things would form. So let's look at lithium, and let's look at fluorine. Now we automatically know how to write a formula between lithium and fluorine. It would just be LiF. And we know that the lithium is going to take a +1 charge in its ionic form, and the fluorine is going to take a -1 charge in its ionic form. That's why we get this LiF formula. Now, if you've forgotten how to write these formulas, go back and review them. We're going to be doing this a lot for the rest of the semester. So we'll still be following the ionic bond rules that we learned way back at the beginning of the semester. So let's take a look at the electron configuration for both of these, and then let's draw the orbital diagrams and see what we would need to do in order to create that LiF compound. So here we're going to have a 1s2, 2s1. That is the electron configuration for lithium. There are 3 total electrons, 2 are in the 1s, 1 is in the 2s. For fluorine, it's a little bit more complex. It's a 1s2, 2s2, 2p5. So that's fluorine's electron configuration. This is a neutral lithium and this is a neutral fluorine. So let's draw a quick orbital diagram for both of these. So we're going to be looking at the orbital diagrams. We should be pretty well versed in how to write these. We know that we draw a box for each of the s's, 1s, 2s. We fill according to those 3 different principles. Aufbau principle states that we fill in the lowest energy state first. Hund rule says we fill in half filled, then full filled. And Pauli's exclusion principle says that we can only have 2 electrons in a single box. So we have these 2 electrons in the 1s, 1 electron in the 2s is going to be given an up arrow. So this is the orbital diagram for lithium. Let's look at the orbital diagram for fluorine. 1s, 2s, and 2p. We're going to have a 1, 2, 3, 4, 5, 6, 7. This is Hund's rule. You fill all up first, then all down. And that is the orbital diagram for fluorine. Now let's take a look at this. We know that 8 is a magic number. We know that 8 is the magic number in chemistry just because if we were to neglect the core electrons for fluorine, which would just be the 1s2, the valence electrons here would be 7. If we were able to gain 1 more electron in this fluorine, we could have a fully filled set of 8 valence electrons. That's what we're shooting for. If we look at the lithium, this is our core electrons, it's fully filled. This 2s, there's only 1 electron. If we were able to drop that electron off, then we would have a full set of core electrons. That would be happy as well. So that's exactly what we're going to do. We're going to take this electron, and we're going to donate it to the fluorine. So now what happens, I'm going to redraw this. This, as it is drawn now without this arrow, is lithium and fluorine. I'm going to save time and space by now rewriting this as lithium plus. So now this is gone, as well as this. Our new electron configuration for lithium plus is going to be a 1s2. We've lost one electron, but now you can see that down here in the 1s we have a fully filled orbital. Great. This electron was donated to the fluorine, so this becomes F minus. We change that 5 to a 6, and we add a down arrow. Now, all of the boxes are fully filled. We have a complete set of 8 for our valence electrons. We have complete set for our core electrons. These both satisfy the octet rule. That's very nice. So the way that we would draw lithium is we would just write an Li plus. There is no dot, there are no dots because there aren't any valence electrons. And next to that we would draw the F minus. This would have a set of 8 valence electrons. So we'd have 1, 2, 3, 4, 5, 6, 7, 8. And this is how you would draw the Lewis dot structure for lithium fluoride. We're going to have an Li plus, an F minus. The F has 8 dots surrounding it. The lithium has no dots surrounding it. So this is our Lewis dot structure for an ionic bond, a cation and an anion. So we'll be talking about this more extensively tomorrow in class. We'll be doing a lot of examples of this, but for right now, all we need to know is the lithium, the cation, has no dots, and the fluorine, the anion, is going to have a total of 8 dots. That won't change throughout the rest of the semester. With that, I want to say have a great night. I will see you all in class tomorrow.